When you turn on a hot tap and wait, you are not waiting on your water heater. The heater already has hot water ready to go. What you are waiting on is the slug of cold water sitting in the pipe between the heater and the faucet. That water has to drain out of the way before the hot water behind it can reach you. A hot water recirculation system fixes exactly that. It keeps hot water moving in a loop so it is already sitting at the faucet when you open the handle, instead of starting its trip from across the house. That is the whole idea in one sentence. But how it actually pulls that off is more interesting than it sounds, and there is one setting on these systems that decides whether it saves you money or quietly raises your bill. Most people who install one never touch that setting, and they pay for it every month without knowing why. I have spent days digging through plumbing manuals, manufacturer specs, and the threads where homeowners complain about what went wrong after they put one in. So let me walk you through how recirculation really works, the two ways it gets plumbed into a house, and the one control choice that makes or breaks the whole thing. Start with the problem it solves. In a normal house, hot water only moves when you open a tap. The rest of the time it sits still in the pipes and slowly cools to room temperature. So every time you go to wash your hands or start a shower, the first thing out of the pipe is yesterday's hot water, now cold. The farther your faucet is from the heater, the more cold water sits in that line and the longer you stand there waiting. In a big house with a long run of pipe, that wait can stretch past a full minute. Across a year, the average American household runs something like 11,000 gallons of water straight down the drain just waiting for it to turn hot. A recirculation system attacks that by never letting the hot water sit still and go cold. At the core of every system is a small pump, usually a little electric unit about the size of a softball, mounted right at the water heater. It draws hot water out of the tank, pushes it through your hot water pipes past your fixtures, and sends the cooled water back to the heater to be warmed up again. That constant slow circle keeps hot, or at least warm, water parked close to every tap, so when you open the faucet, hot water shows up almost right away instead of a minute later. There is one more part that matters, which is the check valve. It is a simple one-way gate that keeps the water flowing in a single direction around the loop, so the hot and cold lines do not just freely mix into a lukewarm mess. When a recirculation system goes wrong, a stuck or worn check valve is one of the most common culprits, so it is worth knowing it is in there. Now here is where systems split into two very different designs, and which one you have changes how well it works and what it costs. The first design is a dedicated return line. This is the real full loop. A separate pipe runs from the farthest fixture in the house all the way back to the water heater, so the water has its own private road home. The pump sits low on that return line on the cooler side of the loop. This is the best performing version by far because it never touches your cold water plumbing. Cold stays cold, hot is genuinely waiting at every tap, and there are no strange side effects. The catch is the pipe itself. Running a brand new dedicated line through finished walls and floors in an existing house is a big invasive job. Retrofitting one into an average-sized home can run somewhere between $4,000 and $7,000. That is why dedicated loops are usually put in when a house is being built and why bigger and higher-end homes tend to already have one. The second design is the one most people actually add later, and it is a clever workaround. It is called a comfort valve or crossover system. Since most existing houses do not have a spare return pipe, this design borrows the cold water line to send the water back. A small thermostatic valve gets installed under the sink that is farthest from the heater, usually the last bathroom on the run. When the hot water in that line cools below about 95 degrees, the valve opens and lets the cooled water cross over into the cold pipe which carries it back to the heater. Once hot water arrives and the valve senses that warmth, it closes again. No new pipe, no tearing open walls. The pump itself runs about $200 to $750, and a straightforward install is just a couple of hours of work. The trade-off with the crossover design is right there in how it works. Because it dumps warm water into your cold line, the cold side can run lukewarm at first, especially close to that valve. Run a cold tap or flush a toilet and you might briefly pull warm water before it goes properly cold. With the valve set up right and a good temperature sensor, most people say it is minor and they stop noticing it. But it is the #1 complaint with retrofit systems, and a dedicated loop avoids it completely. So that is the real choice between the two designs. A dedicated line costs a lot more but works cleanly, while a crossover system is cheap and easy but borrows your cold water to do the job. Now for the part that actually decides whether this whole thing is smart or a slow money pit. It is not the pump or the design that settles it. It comes down to how the pump is controlled, which really just means when it is allowed to run. There are 3 ways to do it, and the gap between them is huge. The first is continuous. The pump just runs all day, every day, keeping hot water circling around the clock. It works and you get instant hot water anytime you want it. But running non-stop, the pump keeps your pipes full of hot water 24 hours a day, and hot water in a pipe constantly bleeds heat into the surrounding air. Your heater has to keep replacing that lost heat over and over. This is called standby heat loss, and it is the hidden cost nobody warns you about. Between the pump electricity and all that wasted heat, a continuously running system can quietly add somewhere from $100 to a few $100s a year to your bills. In some homes, that is more than you ever save on water. The pump motor itself is cheap to run. The heat it keeps leaking is the expensive part. The second option is a timer. You set the pump to run only during the hours you actually use hot water, like a window in the morning and a window in the evening. The rest of the day it sits off and stops bleeding heat into your walls. This is a solid middle ground. You get instant hot water when you need it most and cut a big share of the waste. The third option is the smart one, and it goes by a few names: on demand, or temperature controlled, or button activated. Instead of running on a clock, the pump only kicks on when it is actually needed. Some versions use a temperature sensor that runs the pump just until the line is warm, then shuts off. Others use a button or a motion sensor, so you tap it as you walk into the bathroom and the hot water is ready by the time you are about to step in. This is the most efficient setup by a wide margin. It can cut the pump's electricity use by nearly 90% compared to running continuously, and because the water is not sitting hot in the pipes all day, the standby heat loss almost disappears. This is the version actually worth installing. So if you take one thing from all this, let it be the controller. The exact same pump and pipes can either save you money and water or slowly cost you more every month. And the only difference is whether it runs all the time or only when you need it. If you ever inherit a house with a recirculation pump that just runs non-stop, putting it on a timer or a demand control is often the single best thing you can do to it. One quick note if you have a tankless water heater, because recirculation gets tricky there. A tankless unit only fires up when it senses water flowing. A pump running constantly would make it fire over and over all day, which kills its efficiency and can wear the unit out early. So with tankless, you really want a demand-controlled pump, not a continuous one. A lot of newer tankless models from brands like Rinnai and Navien come with a built-in recirculation pump and a matching valve designed to work with it, which is the cleaner way to go if you are buying new. So is a recirculation system worth it? If you have a big house with long pipe runs and a real wait for hot water, it is an easy yes, as long as you run it on demand or on a timer. If you care about not pouring thousands of gallons down the drain, same answer. But if you live in a small place where the hot water already shows up in a few seconds, the payoff is thin, and just insulating your hot water pipes might get you most of the comfort for a fraction of the cost. Either way, you now understand what is really going on inside one of these systems. The pump doing the work is the simple part. The two designs are just two different roads the water takes home, a private return line or a borrowed cold one. And the thing that quietly decides whether the whole setup helps you or works against you is that controller. The choice between running all day and running only when you need it. If you are shopping for a pump, a timer kit, or just some foam pipe insulation to try the cheap fix first, I have put options for all of it down in the description so you can see what fits your setup.